All right. Hello, everybody. We're going to be going over the Pythagorean Theorem today. So everybody log into Pear Deck. Miss Buckley, Miss Calderon, and me will be sharing how we can prove the Pythagorean Theorem today. So let's everybody log in. And I do want to remind everybody that we are using our interactive notebooks, so take those out. Open up to page 24 and 25. We're going to be taking our notes on page 24, and our worksheet should already be pasted on page 25. So if it's not there, go ahead and make sure you leave it out to work on. All right, I have 10 students connected, 11, we're almost there. All right. So I'm going to go ahead and start. Remember, the code's at the corner if you guys haven't done it yet. All right, so the Pythagorean Theorem. So everybody, let's drag our triangle on the screen. Show me how you're feeling today. Are you guys feeling grumpy? Are you guys feeling over? Are you hungry? Let's see what we're feeling.
Well, you guys how are you guys excited for your Thanksgiving break coming up? How are you guys feeling about it?
Yeah.
Alan's excited.
Anybody want to share what you guys are going to be eating? Maybe I can get some recipes from you guys.
Ooh, that would be great.
No, nobody wants to share? Okay, I'll share. I'm going to have lots of ham. I don't know why, but we love ham over here at my house. So we're not going to be eating turkey. We're just going to have lots of ham, glazed ham with pineapple. Oh, somebody's grumpy. Okay, let's try to change that. Somebody share with me their recipes. Okay, I guess nobody wants to share. That's all right. All right, so before we get started, we have our objective for today. So students will be able to define and apply the Pythagorean theorem to solve problems. And the standard we're going to be addressing is applying the Pythagorean theorem to determine unknown side lengths in right triangles in real world and mathematical problems in 2 and 3 dimensions. So we might not get to 3 dimensions, but we will definitely get started on the 2-dimensional ones. All right, so I will be reviewing the classifying triangles with you guys and giving you a little bit of review. So you guys should have all looked up the Ed puzzle over the weekend and should have reviewed it. If you haven't, we'll go over it again. Make sure you're writing down those notes on page 24. Miss Buckley will go over the Pythagorean theorem with you guys. And Miss Calderon is going to do the 3, 4, 5 triangle activity that's on your worksheet. And at the end, we're going to quiz you guys on Kahoot, so make sure you're paying attention. All right, so from your video, we should have received information on how to classify triangles. So we have 2 ways to classify them. We have by angle and we have by side. So if we pay attention to the by angle ones, we see that it tells us that all angles inside have some number that we have to focus on. So for the acute angles, they're all 90 degrees or actually less than 90 degrees. So that's why it's called acute. It's kind of a reference to being a cute little triangle. So that's how a little tip on how you can remember it. A right triangle, you can see this corner right here has a little square. That means it's a 90-degree angle. So that's why we call it a right triangle. And obtuse is opened wide, really wide. So it's over 90 degrees and it is obtuse. All right, and by side, we have an equilateral triangle where all sides are equal. So this side's equal, this side's equal, this side's equal. Notice that we don't have any numbers because we can totally gauge from it how each side is the same. And isosceles has 2 sides that are equal. So this side is equal to this side. This side's a little bit longer. And a scalene has none that are equal. So it's a wonky little triangle. All right. So I want you guys to help me out. Show me that you guys are paying attention. Let me see you drag your triangles over to the correct spot. So a red triangle should go on an equilateral. An orange should go on an isosceles. A yellow should be on scalene. And a blue should be on a right. So remember that these are classified by their side. So we don't see any numbers on here.
And if you guys need additional help, think about the words. A right triangle. What does a right triangle have? An equilateral triangle. What does that word sound like? Equilateral.
Good. Let's see. Oh, I see almost perfect responses. Oh, it's not active.
You guys are doing so good.
Okay, I'm sorry, guys. The computer's acting up, but I can see everybody is almost on the right ones. Good.
There
I
you
see
go.
blue on the right. Good job.
There you go, guys. Good
Look at
job.
the wonky one. The wonky one is what? A scalene. Good. All right, good. So then if you guys still have issues with that, remember you have to rewatch the Ed Puzzle video. Okay, let's go ahead and move on. So here's another one. What type of triangle is this one? Remember what we discussed.
It doesn't look like any of those sides are equal. What do you guys think? What do you think, Cecilia?
I don't know. I can't really tell. Does there need to be numbers? What did I say about the numbers? Let's see. Good. It's a scalene. They're all different. All right, Jolene, what do you think this triangle is?
Well, the two lines look about the same size, but the third one doesn't. So I don't think it's an equilateral.
Oh, good. Everybody got it right. Oh, somebody's changing their mind. So remember, equilateral is equal. So every side needs to be equal. We can tell that these two are longer. All right, pay attention to the next one because we're going to be doing our whole lesson on this triangle.
This one is the important one right here.
Of course. So remember that little thing on the corner? What does that make this triangle? Right triangle. Good job.
You guys are on it.
Triangle always has this equal to 90 degrees. All right. So if you didn't get that down, make sure you write it down in your notebook. All right, and we're going to go over some algebra review with you guys. I know you guys are very smart, so this is just going to be a quick review. We're going to be reviewing x squared. Can anybody tell me what this x is? What is the mathematical term for this x? Can anybody speak up and tell me?
Variable.
Good job. It's a variable. So variables actually stand for any number. Can anybody tell me another type of variable you can think of? What's another one?
Y.
Y. Good job. Anybody else?
Ooh, there's a lot in the chat.
Oh, can you read the chat for me?
Yeah.
Yeah.
We have A, Y.
Oh,
B,
wow.
C.
Okay, good. Perfect. So
Any
everybody
letter.
understands what the variable stands for. So we're going to be focused on A, B, and C for this lesson. So just keep that in mind. So if you guys remember, an x squared means that any number that's in for that x needs to be multiplied twice. So if we have 5 squared, it's going to be 5 times 5, which we all know is 25. And if we have 9 squared, it's going to be 9 times 9, which is 81. Then we have the square root. And that square root lets us know that that number inside the square root will have an answer that's the same number multiplied by itself. So the square root of 25 is 5 times 5, so it's 5. The square root of 81 is 9 because 9 times 9 is 81. Now, can anybody tell me what the similarities between these two are? I'll give you a hint. They kind of sound the same because if you do the same thing, if you do an x squared over here, this cancels out. If you do an x squared over here, this cancels out. So that's what we call an inverse. So an inverse means they cancel each other out. So let me give you an example. If we have 81 squared, or the square root of 81 squared, then it would be 81 because these two notations cancel each other out. Same thing over here. Square root of 9 squared is 9. All right, Miss Buckley, you're going to go ahead and get us started.
Okay, will you go to the next slide, please? Okay, guys, so here is a word you might remember or it could be new to you. It's kind of a funny looking word. It's very long. So why don't you guys all go ahead and unmute yourselves. I'll say the word and I want you guys to all repeat it, okay? I want everyone to participate. So this word, it sounds like hypotenuse. Can you guys say hypotenuse?
Hypotenuse.
All right, cool. Sounds like everyone knows it. Let's try one more time. Hypotenuse.
Hypotenuse.
All right. Good job, guys. Okay, so what is a hypotenuse other than a long, crazy word? A hypotenuse is the longest side of a right-angled triangle. So only right-angled triangles have a hypotenuse.
I'm sorry.
You're fine. And then another definition for a hypotenuse is the side opposite of the right triangle. So do you guys see where it says legs and how in the middle of those is that red box? That indicates that it's a right angle. So that's a right triangle. So opposite of where that box is that indicates the right angle, opposite of that is the hypotenuse. So the hypotenuse is referring to that very long side opposite of the right angle. And then the other two sides are called legs. Okay, so what we're going to be learning today is the Pythagorean theorem. Can everybody say Pythagorean?
Pythagorean.
Pythagorean.
Awesome.
I don't know how to say it.
I'll help you. Pythagorean.
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 Awesome. That sounded so good. I'm so proud of you. Good job. Okay, so the Pythagorean theorem. First off, it's an equation. It helps you to figure out the missing side of a right-angled triangle. So if you look to the image on the left-hand side of that book, does everyone see where it says a squared plus b squared equals c squared? Give me a thumbs up if you guys can see that. Awesome. Everyone looks like they know what they're looking at. So that equation right there, that is the Pythagorean theorem. So when I say that, what I'm talking about is a squared plus b squared equals c squared. That's the formula. Everybody write it down and highlight it, do whatever you need to do, because that is the most important thing from this lesson, is knowing that formula. So to help you, just think a, b, c, and then all of them squared. It's a really easy formula. Now let's explain how this formula fits in right-angled triangles. So the C is always going to be the hypotenuse, no matter what number it is, where it's at in the triangle. C is always going to be the hypotenuse. Now the A and the B are going to be the other sides of the triangles, the legs, and those are interchangeable. It doesn't matter which one's A or B. The main thing that matters is that C is your hypotenuse. So how the Pythagorean theorem works, it only works with right triangles, okay? It doesn't work with scalene, it doesn't work with isosceles, only right angle triangles. And you have to know the length of any two sides. So what that means is if you know the legs, but you don't know the hypotenuse, then you can use that formula to find the hypotenuse. Or if you know one leg and one leg and the length of the hypotenuse, then you can use the formula, plug those numbers in, and then you can find the length of the other side. So it can be any two sides, but you just have to know two of them. And then again, the legs are what fall on either side of that right triangle, and the hypotenuse is opposite of the right triangle. Does anyone have any questions so far? No? Okay. How about Doug? Can you tell me what kind of triangle the Pythagorean theorem works with?
Only with right triangles.
Awesome. Good job. Thanks for paying attention. I hope everyone else is paying as good attention as Doug. All right. You can go to the next slide. Okay, so here's a little bit of history of the Pythagorean theorem. So the Pythagorean theorem came from a Greek scholar named Pythagoras. He lived around 500 BC. Pythagoras he had a cult-like group which was called the Brotherhood of Pythagoreans. Now, this was a kind of a strange group. They were devoted to the study of math. They had their own school where they all lived, and they were all devoted to math. This group believed that numbers ruled the universe, and they wanted to keep all of their findings a secret. And it's actually for this reason that we don't even know if Pythagoras is the actual person who created the Pythagorean theorem. It's just named after him. So no one really knows. It's kind of a gray area. But he made everyone that was at this school take vows of secrecy. And it's because of this reason of secrecy that we don't know where it actually came from. The Pythagorean theorem could have came from one of his students and was just named after him. We don't exactly know. But what we do know is about 2,500 years earlier, way before Pythagoras lived, Egyptians actually had the triangles, what are they called? The
Pythagorean triples.
Thank you. The Pythagorean triples, not triangles, written on a tablet. So what this means is that the Egyptians, way before Pythagoras' time, were actually using the same information. And they use this information for things like scaling land. But we'll talk about that in the next slide. Okay, so ancient Egyptians used the Pythagorean theorem to survey land around 3000 BC. And this is a little image of how they did it. So if they had a square of land and they needed to survey it, they would cut it diagonally, which is what class? What is that diagonal line? Does anyone know? The one that's opposite of the right side triangle?
The hypotenuse.
Good
Awesome.
job.
Good job. And so anyways, they would use the Pythagorean theorem and these triplets to really survey the land. Now, can anyone else think of any other ways that you guys could use the Pythagorean theorem today? Maybe in building something that has to do with triangles?
Because I actually know an interesting one.
Share it.
So a lot of people at NASA think that it could be the key to communicating with alien life because math is a universal language. And the Pythagorean theorem is an easy way to get that direct translation across.
Wow, that's new information to me. Good job. Thanks for sharing. Okay, so can anyone think of any ways here on Earth that we use the Pythagorean theorem?
Yeah, Jolene gave you guys a quick reminder. It's in buildings. Can anybody think of what type of buildings we might need this for?
Oh, I see someone said roof. Carrie, good job. That's exactly right.
Great. Yes.
Floor planning, that's great, especially if you're someone who uses tile. That's a really good one. Churches, laying out foundation. Okay, so we shared some images here. The bottom left actually shows an image of the roof where it's being used. The bottom right, does everyone see those roads? So actually, you can actually use that today when you guys all start driving someday and you let me know so I know to stay off of the roads. You guys can use the Pythagorean theorem to figure out the shortest distance to get somewhere. So it's really handy for driving. And I know everyone here wants to drive. And then above that picture is an image of the golf course. So you can actually measure your distance if you're going to have to hit a ball diagonally into a hole and you need to gauge the distance. And then on the top left is another way to use it in construction. Okay, so here's a short video on how the Pythagorean theorem works. I want you guys to take notes, follow along, highlight what you need to highlight. Make sure you guys copy her problem down and work it out with her.
This example,
Can you guys
notice
stand
that
up?
we have a right triangle, so we can use the Pythagorean theorem. The Pythagorean theorem states that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse, or a squared plus b squared equals c squared, where A and B are the lengths of the legs of the right triangle, and C is the length of the hypotenuse. So here, since the legs of the right triangle have lengths 6 and 8, and the hypotenuse has a length of x, we can set up the equation 6 squared plus 8 squared equals x squared. Simplifying from here, 6 squared is 6 times 6, or 36, and 8 squared is 8 times 8, or 64. So we have 36 plus 64 equals x squared. Next, 36 plus 64 is 100. And we have 100 equals x squared. Now to get x by itself, since x is squared, we take the square root of both sides of the equation. On the right, the square root of x squared is x. And on the left, since 100 is the perfect square 10 times 10, the square root of 100 is 10. So 10 equals x. Notice that we don't use plus or minus 10 because x represents the length of the hypotenuse of the triangle, which cannot be negative. So the value of x is 10.
All right. So if everybody paid attention, that 6, 8, 10 is actually a Pythagorean triple, which we were referring to it earlier. And another Pythagorean triple that we're going to review is with Miss Calderon. So on the next slide, we're just going to really quick check to see if you guys are paying attention. Miss Calderon, can you go ahead and get started?
Yes. All right, guys. I hope we're doing great. I hope we're all understanding it, but let's see if you guys are. So really quickly, you're just going to go ahead and drag your triangle to answer the question that I will ask you. So true will be over there with Michael. Drag it over there to him, or false would be over to the other guy. I don't know his name, but Kevin.
That is Kevin.
All right. So first question. We can use any triangle for the Pythagorean theorem. True or false?
Good.
We can use
Almost
any
there.
triangle. Okay. Just 2 more. Just scoot them right over. No, 3 more.
Yeah.
There you go. Good job, guys. Yes, so the Pythagorean theorem can only be used with what triangle? Can somebody tell me? You can put it in the chat too if you don't want to speak up. That's cool. Awesome. Right triangle, yes. Awesome. All right, next question. Right triangles have 190-degree angle. Awesome. I see students moving it over. Yeah, so right triangles do have 190-degree angle. Only one. Remember, it's the one with the little square at the corner. All right, next question. The hypotenuse is the shortest side. True or false? The hypotenuse is the shortest side.
Oh, I see some
Alright.
people not decided. Remember, the hypotenuse is across the right angle, so it's the biggest side.
It's the longest.
So everybody's down. 2 thumbs down. It's the longest side, correct?
Yes, so we should
All
all
right,
be
for
with
time's
Kevin.
sake, yes. We're going to move on to our worksheet.
Awesome. All right, guys, so we should all have our worksheet that we sent out earlier. Make sure you are copying down on the worksheet because it should be in your interactive notebook. But you also will be sharing with us here on the screen. Awesome. So
And I just want to add, I'm going to be
Yes.
doing it on my handy dandy whiteboard. For anyone that wasn't able to get the resources to print theirs out, I know right now it's hard to get some resources.
oh, yes. Thank you, Miss Buckley. Perfect. All right, guys. So this theorem only works for blank triangles. Go ahead and fill that out and then complete the formula for us. What should be the first variable there? And what should be the exponent on that?
Good. I see right triangles. Let's see. Good. A squared plus B squared.
Awesome. You guys are doing great. All right.
90-degree triangles, that's the same thing.
Ooh.
Good job. Right, I hear you guys. Oh, perfect. Good, so it looks like everybody knows that it only works for right triangles, and we know our formula. So make sure you wrote that
Awesome.
in your notebook as well.
Yes, we want to make sure you guys have that for later. All right, great. So this is also the bottom portion of your worksheet. So together we are going to show that the Pythagorean theorem is true. All right. So for this activity, just keep in mind that this is a 3, 4, 5 triangle. All right, which is also called a. Does anyone remember what type of triangle that is?
A Pythagorean triple.
Some people
Yes, awesome. Yes, a Pythagorean triple. And there is also other Pythagorean triples again, like Ms. Ordonez and Ms. Buckley said. We have the 5, 12, and 13, and the 7, 24, and 25. There's other ones as well. Very good, guys. All right, so what we're going to do here is, again, we're going to prove that the Pythagorean theorem is true. Using colors. So you will need, for your interactive notebook, you will need 2 colors. We're going to be using red and blue. And then just make sure you fill that in, okay? We want to make sure you have that on your worksheet. Great. All right. So for the first one, we are going to be filling in red. So make sure you have your red color pencil or marker, whatever you're using. And we are going to color our A. Awesome. Thank you. So everybody go ahead and color your A, which is going to be our bottom leg of our triangle right there. I'll give you guys like a couple seconds.
Yeah, and this is our 3 by 3, right? Or square, my bad. The 3 by 3, so that means 3 times 3 is what?
What do you guys
9.
think? Very
9
good. Yes.
9. And that is actually the area of it, because we can count the little squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that the area of that little square is 9.
Very good. Yes, guys. Awesome. All right. And now we are going to fill in our B, which is going to be our other side of our leg. And this one is a 4 by 4. So how many are totaled in there? How many little squares do we have? If it's a 4 by 4. 16, yes. Shabrita, Leticia, very good. Rogelio, Jessica. Awesome. Perfect. Yes, that is 16. So there's 16 of those, and then there's 9 of those. So these are 2 of our legs, and if we want to prove that it actually works, so they both equal the hypotenuse, which is our C, then we are going to combine them now. So go ahead and go to the next slide. Thank you. So we can actually put our 3 by 3 in the center. Again, you can put it any way, but we're just going to put it in the center so you guys can have a better visual of how they actually equals to it. And then we can put our B around it. And if you guys want to count it so we can see that it does actually equal it, as you can see, our 3 by 3 fits perfectly in there, and you guys can count that it is a 3 by 3. And if we count all the way around that blue surrounding the 3 by 3, there is actually 16 there. So you guys can count that in your worksheet so you guys can see for yourselves.
Yeah.
All right.
And 16 plus 9 is 25, which is what we have. 5 by 5, which is 25. So you just proved the Pythagorean theorem.
Woohoo. What do you guys think? Cool, right?
Very.
All right, guys. So we can finish the rest of our worksheet. Just want to remind you guys again, this was from the beginning of the presentation. Remember that when we square something, that means we're multiplying it by itself. So 5 squared is 5 times 5. And then when we take the square root, where it's 2 numbers, same number, multiplied gets that square root. Okay? Just remember that for the next one. The next slide. Awesome. All right. So again, this is also in your worksheet. Make sure you fill this in. So go ahead. I'll give you guys a little time to. We'll give you some time to fill that out. For your convenience, we put our A, B, and C in the side so you guys can know what we're talking about.
Yeah. We're going to check on your
Okay, so try and fill that. Remember.
Wow, you guys are getting it. Yes. Perfect. 25. Good.
Oh, you guys got this. Awesome.
Using the correct numbers. Perfect. 25 equals 25. So what is C? Waiting to see who gets the answer first.
Ooh, come on, guys.
Oh, I see one right here. C is actually 5. Good. So this is our 3, 4, 5 triangle that we were just working on. Good. So make sure that as you finish your work, good job. I love this one. You're also copying down in your worksheet because you're going to need that to study. All right. How are we
Good job,
doing
guys.
on time?
We have some time.
All right. So we're going to move on to our Kahoot. So Miss Karina, Miss Calderon, if you'd like to share your screen.
Yes. All right, guys. Go ahead and open up Kahoot. Meanwhile, I share this. All right, awesome.
So we want everybody to join in the Kahoot, type in the little code that was there. That's right.
Let me move this. You guys can see the code, right? The pin? Awesome. I see some students are joining. I'm turn this off. All right, guys. Let's see if more students join. Ooh, A+ student. Let's see. We have 1, 2, 3, 4, 5, 6, 7, 8. Your names. Awesome. All right, guys. I'm gonna go ahead and get started. I don't know if you guys want. You guys should probably get your notebooks out so you can show your work, and then you can use it as notes for later on. Okay. So make sure you have that out. Okay, guys. I'm gonna go ahead and start. You do have about 10 seconds for the first ones, and then you have a minute for the last one. So make sure you read quickly, but also answer to the best of your ability. Okay. Awesome. All right. Number 1, what type of triangle is the Pythagorean theorem used for?
What happened to the noise?
Ooh, sorry.
Triangle. Good.
I don't know if you guys can hear it. Awesome, guys. You guys all got it.
Good
Great.
job,
You guys are paying
guys.
attention. Ooh.
C-squared. I love that name.
All right. How can we determine which leg of a right triangle is the hypotenuse?
I went over this very well, so I hope you guys get it.
Oh, yes, she did. You guys got this.
There's a misspelling on the board. Just
What?
ignore it.
All right, let's see. It's the longest. We got mostly that one. It's diagonal. It's the opposite of the right angle. All right, so it should have been all of the above. I mean, you guys didn't get it wrong. Just
Yeah.
didn't get all of them. Good job, guys.
Good job, guys.
All right, next question. So I was going to show a picture right now. What color squares are attached to the legs of the right triangle? The legs. Ooh, we're running out of time. Come on, guys, you got this. It was the blue and the green. Good job. Most of you got that. Good job, guys.
Good job, guys.
All right, what color is the hypotenuse? Pink, blue, or red? Ooh, very good. Yes, it was the red. Remember, it is the longest. It is also the one opposite of the right angle. Awesome, guys.
That would have been too hard, Douglas. You guys would have been too confused.
All right, how would you set the Pythagorean theorem for the following right triangle?
Ooh, this is a good question, guys. Take your time.
Asking you to set it up. Pay attention.
Think about it. Remember, there's one side that has to be in one part. One specific part.
Ooh, well, if you got A and B, you guys were right, but it's actually both of them. Remember that the A and the B don't matter. Doesn't matter if it's first A or first B. It doesn't matter as long as the C is by itself. Awesome. Six out of eight. So which of the following squares would have the largest area? Ooh, this one's I don't know if I think you guys should be able to get this one. Remember, the area is the total number of squares.
So look at where the hypotenuse is.
Oh, almost all of you got it. Awesome. Yes, it was the pink because it is the opposite of the right angle. If you clicked the yellow one, it's pink because it's A. It is pink, but it's not A, right? A would be one of the legs. Awesome. All right, I believe we have like 2 more left. Okay, so solve for X. You guys have a minute for this one, so take your time.
Rita.
If you guys paid attention to the video, this should be easy.
Remember which one is your C. Start there, that helps. Oh, you guys are answering fast. You guys got this.
Let's go ahead and
Let's
can you show the answers? Yeah.
All right, let's see.
Yes.
Ooh.
It looks like you guys forgot to square both sides if you guys got 100. So remember, you had to use the inverse to find the square root of 100.
So that was kind of a trick question.
Don't forget that last step. We gotta square them.
Very important. All right, last one, guys. We have to finish strong. You guys got this.
All right, everyone get this one. I have faith in you guys.
Find the length of the hypotenuse.
Oh man, I have to do math?
Think about the last problem and what your answer was. And then think about this one.
So 2 of those answers should kind of already be in your head. Oh, well, that's too big, right? You probably forgot to square those answers. Oh, you guys, almost all of you got it. Awesome. Yes.
Good
You're
job, guys.
smart. Good job, guys.
All right, awesome job doing the assessment. I hope that you guys had fun learning about the Pythagorean Theorem. Make sure you hold on to your interactive notebooks because we will be reviewing them tomorrow during our next lesson. All right, thank you guys.
Good job, guys.